I'm Mark van Oostendorp, and I think the advent of so-called large language models a few years ago um, has been very important. Very important, probably in many different aspects, but also very important for our thinking of what language is and what language isn't. Because it looks like these models can use something very similar, at least, to human language quite successfully, although not successful in every possible way. So, but in certain ways, which are very impressive and which I have to admit I wasn't expecting until very recently. And then the advent of ChatGPT and other chatbots, which are like applications of those large language models, and which became available to non specialists like a year ago, makes it possible for us to study human language, I think, in new and interesting ways. And I'm a phonologist. I'm interested in so called formal phonology, which means I'm interested in trying to describe knowledge of phonology. What do people know when they know phonology? And then to describe this in a formal way, which means to try to be as precise and specific as we can. And that has been an enterprise which has had successes over the past 50, 60, 70 years. Um, Successes in the sense that there are certain things of which I think we can say we know them. Formal phonologists tend to not agree about anything, but that is because they don't agree about the things we don't agree about. About names, how do we call these things? Or how do we precisely implement these ideas? But there are several ideas which I think we all share. And they boil down to the fact that there are certain restrictions on what is a possible phonological system, what's a possible sound system. For instance, I think it is it's very difficult to argue against the existence of something like phonological features. You can call them elements, you can give them other kinds of names, but it's difficult to argue against their prominence in language systems, in the way in which language seems to be treated in the brain, etc. There seems to be something there. Categorical units smaller than phonemes, segments, consonants, vowels. Small things organized in autosegmental tiers, organized in such a way that every feature, or at least some features, seem to behave separately. We all work on something like the prosodic hierarchy, at least on the insights which are expressed in the prosodic hierarchy. Some of those insights, at least, seem to be universally shared. People may not believe a word of what Nesper and Vogel have to say in their book on the precise implementation, but I think it's really a finding, I think, of our field that prosodic structure, higher order phonological structure, is influenced by syntactic structure, but not exactly uniform, because it has its own requirements as well. But the influence also only goes one way, namely from syntax to phonology, and not the other way around. That's I think what we have found time and again in language after language, and it's something which is real, and it could have been different, right? So those are all of those things are things which we know. It's knowledge. It's what we know how phonological systems work. It's restrictions on phonological systems, and they are real, I think. Just like what we think we know about computation points to restrictions. It seems that phonological operations tend to be extremely local, and when they're not on the surface extremely local, that might be because we're thinking about them just in terms of segments. If we think about them in terms of autosegmental tiers, then they do become local. So that's also restrictions. We have found that Phonologies of the world's languages tend to be simple or simple things. And the question is, why are they simple things? Now, it looks like, at least to some people, it looks like these large language models question this, right? They challenge this. There have been many challenges across the decades, but this may be the strongest challenge because sometimes an argument, as it was presented as an argument in favor of these kinds of restrictions, to say, yeah, well, because otherwise the space of possible languages becomes too big and you can, as a learner, cannot learn it, and maybe even a user cannot use it. It becomes so complicated. But now we have a system which is basically a blank slate, because that's what large language models are. They are just statistical machines. They don't care what their input is. They will learn anything, any kind of pattern, and it can learn language, at least to some extent. It can learn language, and that extent is significant, right? I mean, nobody can deny that it can generate things which look like linguistic objects, and they're well formed and they make mistakes. But humans make mistakes too. Maybe these machines make slightly different mistakes, but still, what they do looks very much like language. But is that people like Piantadosi? I think he's the most prominent person now trying to point this out, that here we have a blank slate which can learn language. So isn't that an argument against any kind of idea of innateness? Because it's at least possible in principle that systems which have nothing innate still learn languages. Well, that sounds like a good argument. Or do they? I mean, do these systems really learn human language? Do they learn it in the same way as we do? And even if that's the case, what's the implication of that, right? So even if it would be the case that these systems, we are now dealing with Chat GPT 4. If we get to Chat GPT, I don't know, 6, 7, 8, and they become better and better and better, and then they really become indistinguishable from human output. They pass any kind of Turing test. What does that mean? And they pass it starting out as blank slates. What exactly does that mean? Well, what are these large language models? There's many people who are giving talks about that all over the place. Quickly for now, what's important for us linguists to realize is that there's the name language there, but it's not necessarily about human natural language, because language here basically means some kind of, it says here, unstructured data. Maybe it's actually even better to say structured data in which there are patterns. So they can learn anything. Because they have nothing specific, they have nothing innate, they're not specific to language. They can learn language as well as music or DNA sequences or digital images or board games. Give them many board games, they will learn how to play them. It's just they need lots of data in databases which are basically unstructured, of structured data. Maybe that would have been a better thing to say there. And then they're trained on them to find regularities and basically to make predictions. Given what I've seen so far, this is most likely to be the next word or the next musical note or whatever, what have you. So they are compared, therefore, sometimes to things like the autocomplete function on your phone, right? So you type a sentence, type a few words, I'm sitting on the, and then you get suggestions, fence or chair, or what is the most likely word coming after all of these words. Well, your phone operates on it has learned that from just, I don't know, a few texts, and it looks just at the preceding few words. These systems have learned it from billions of texts, and They look at many more context than just the preceding few words in a certain way, right? And they teach themselves what that way is, what to pay attention to and what not to pay attention to from the context. There was a man mentioned in the preceding text, therefore the pronoun which is used now is more probably he than she, right? So there's the property of gender plays a role in English, so it's something you pay attention to. That's probably how these models work. I say probably because there's many things we don't really know for sure, because it's only the companies who make these systems which work for sure. That's a problem for research. I want to mention at the outset. So they are trained, and then the ensuing model is all-purpose. It just makes these predictions, but then you can train it for certain functions. For instance, to become a chatbot. So then it's trained. These chatbots, they were probably apparently trained by human beings who asked them questions and then rated the answers. And then, so there's another round of statistics. And that means that what these chatbots do nowadays is basically they calculate what's the most likely thing to say at any given point. And then it goes through a kind of filter of what would my audience likely want to hear. That's going to explain some of the results we're going to see, which I want to present here. So this is how this is just a picture which goes around, which shows how those large language models work. I'm not going to show it for long because I'm not even completely sure I'm allowed to show it. Statistical models were criticized by Chomsky at the outset of his career. Statistical models of language, actually these kinds of statistical models of language where you say you predict the next word based on the preceding words. So how likely is it that that given the preceding words we have these words? Well, his famous example was colorless green ideas sleep furiously, where you would say, well, after colorless, green is a very unlikely word. After green, ideas is a very unlikely word, etc. Still, human beings, he observed, have the intuition that this is a grammatically correct, syntactically correct sentence. How can that be, right? So how can that be? Well, so that cannot be statistics, he concluded. Now, that particular conclusion actually was contested already something like 20 years ago, over 20 years ago, where people observed that actually colorless, this particular sentence, although it's very unlikely, it's still many times, I think 200,000 times more likely than furiously sleep ideas green colorless. So where you invert the order of the sentence and you get something ungrammatical in English, right? So there is, at least those people said, there is some correspondence between grammaticality, possibly, and this kind of probability of occurrence. Now that can be contested, but I think what ChatGPT and its colleagues is showing nowadays is more difficult to contest. Actually, Chomsky used this sentence also to prove another point, namely that semantics and syntax are separate, because he said, well, this sentence doesn't have any semantics, but it's still well formed. Now, I asked ChatGPT to draw a picture in the style of Caravaggio on the basis of this sentence, and this is the picture it has drawn. And I think it's a sensible picture. You know, it makes sense. I think you understand that this is an illustration of that sentence. But how can that be if the sentence doesn't have any meaning? So that point is also, you can also contest based on this. Now, in the wake of Piantadosi, I've also done another thing, namely I've asked ChatGPT to give sentences which are based on the same structure, with a similar structure, and it can do that, and that shows that, you know, or does it? Well, maybe it shows that it understands something of the syntax. I mean, it can give sentences with the same syntactic structure, and it's actually, I think there, he says he'll this the system has decided itself that it should also be nonsensical and contradictory, and it's actually less successful in that because roaring waves and full cups and dark stars, all of those are not very implausible sequences of adjective and noun, or stars shine, right? So it's less implausible, I think, than the original sentence, but it shows something, I think, about syntax. It's very simple syntax, but still. So what does this mean? Huh? Now, I have done several experiments, or I have started doing experiments. I'm actually still experimenting with doing experiments because it's not exactly clear how to do linguistic experiments with these machines for several reasons, which I'm going to explain later. But I've tried to do some, and I've done one, for instance, on Dutch, which is my native language, and then Dutch. What's very important in Dutch phonology, well-studied topic in Dutch phonology, is allomorph selection for the diminutive. So there are 5 different forms: je, tje, pje, kje, and utje of the diminutive, and there's a very complex pattern of distribution of those allomorphs, which is partly phonological influenced, but in such a way that you could, at least I think in theory, learn it from the orthography, right? Because of course, the problem with studying phonology and ChatGPT is that, at least, so while in principle you could also build a large language model with sound files, it's still not possible to make it probably as big as ChatGPT is, right? So we don't just have as much material, so many billions of words in spoken form, so easily accessible. Also because those sound files, are bigger than simple text files. But you can, in this case, you can deduce, in principle, the phonology from the orthography. For instance, you can see tje, pje, kje, that place of articulation has something to do with it. You can glean that from the orthography, right? It's clear that prosody would be more difficult to learn for these systems because they have no access to word stress, for instance, right? Because if it's not marked in a language, then how can they ever know where word stress is? Now, I asked 3 of the most prominent, well-known commercial chatbots to give diminutives of a list of first names. So Piet, Karel, Janneke, Esther, Bram, Hilde, Jan, Sting. I asked them each 5 times because they give a different answer every time, and you want to avoid that you are unlucky or extremely lucky and you get something which is not really representative. Now, in this case, it was not necessary to do it more often because basically they did it right in all cases. Or at least in almost all cases. So they did Pietje, Kareltje, Estertje, Brammetje, Jantje, Stingetje, which are the forms which I and basically every Dutch speaker will give. Sometimes it gave strange forms, for instance, S instead of Esther. But there I have to say S is, if I would ask this a Dutch informant, they might also sometimes say S, because that can function in certain circles as not as a diminutive, I would say, but as a hypochoristic, and is clearly not very unlikely that somebody would confuse those 2 different forms. So that's, it's a mistake, but it's almost a human mistake, let's say. However, now if I would ask them to, I also asked them to arrange these forms in some kind of scale of naturalness. And I did this for a specific reason, because hidden in this list there's the form Hilde, and there's a strange generalization about Dutch diminutives, and that is that diminutives of words or names ending in te or de are almost always ineffable, people don't know what to do with them. Everything sounds strange. So Hildetje is strange. Hildetje is actually the form which the chatbots often gave. Hiltje would be an alternative, is also weird. It just sounds strange. Now this feeling that it does just sound strange, that doesn't seem to reach the chatbots. Or inversely, maybe I don't know how to get the chatbots to recognize that they sound strange. When I asked them what sounds strange, they basically always said stingetje sounds strange, because sting is not a real Dutch first name, or sometimes it's said not a Dutch word. That's correct, but actually I think stingetje is not a strange diminutive at all. So given, I'm sure there are children, Dutch children, who are called Sting, just after the musician. And I'm sure that then they will be called without any problem Stingetje. Whereas Hilde, there's many Dutch children called Hilde. I'm sure not many of them are called Hildetje. So there's something going on there, and that's not recognized. Yeah, and yeah, so maybe that is a cue that intuition is lacking. There's another kind of example I have here, which is Finnish vowel harmony. What I did here is I gave it lists of nouns, Finnish nouns, and I asked to give the partitive, and I explained the partitive can be a or e. And this is the answer I gave. And one thing which is very important, and which also happens time and again, is that when you ask a chatbot this kind of linguistic question, they start analyzing it. So this chatbot immediately starts talking about what? About vowel harmony. I didn't mention vowel harmony, right? But it starts with explaining that Finnish has vowel harmony and how that works, more or less, and how it would work in this case. So the answers are always very analytical, right? So it gives some kind of analysis, and then it gives the examples. Now the analysis actually doesn't always really fit what it then does in the real examples. So that might just be a chatbot property that it likes to explain always, because people like to hear explanations from chatbots. That's maybe, it's some kind of ad hoc explanation which it gives afterwards. This is mostly right? So the answers it gives are mostly right. It's also interesting notice that it sometimes explains individual answers, and in other cases it doesn't, and it's not clear why. The main thing where this goes wrong, and I have to say I asked this because these patterns are very complex, in the sense that Finnish has neutral vowels like E at the end of many of these words, and then what typically counts is the frontness or backness of the vowel immediately preceding the E. So in syntaxy, people prefer syntaxia because of the A in syntax, that A, which is preceding the E. So the E doesn't count, you look at the A. That's basically the rule. Well, I don't know. It gets that rule, right? It doesn't explain that rule. It explains vowel harmony in a very simple way. But then in the explanations of individual words, it seems to get something like that, right? The presence of necessitates the use of It's actually not really the right vowel to look at, but E leans towards A. That's not completely true. It's a neutral vowel, so it does lean towards A. However, EI is more consistent with vowel harmony here. So that really doesn't make a lot. So the explanation doesn't make a lot of sense. One reason I asked this is that Finnish speakers, in some of these cases, hesitate, right? So for analysi, 50% of the people give a front vowel, but still 36 give a back vowel, and 14% say both are possible. So, and that hesitation you don't see. You don't see never. You don't see that in these systems. Again, maybe that's because of the chatbot quality of them. That they think that people like to hear one answer and not, well, maybe that and sometimes that. That might be a possibility. So that's why I then asked it. It had given me Annalisia. I asked it, would Annalisia also be possible? And then again, it doesn't then say, well, yeah, there's variation. It says, yeah, no, no, now all of a sudden, Annalisia is the correct partitive singular form. I apologize for the oversight. So it now basically no longer recognizes its original answer, which was also correct, right? So it's slightly less common, but it's still correct, according to a large percentage of Finnish speakers, at least in the study I've shown you. Now, it's not the case that it tries to please you so much that whenever you ask, well, would this also be possible? It says, yeah, 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 of course. So I also asked it, would Tabasco also be possible, where there's only back vowels? And so there's no way that that's possible. And then it does also says no way. So no. Then it says no, it's not correct. So it's not pleasing or trying to please all the time. So yeah, what exactly is going on there is difficult to see, right? So it's difficult to understand. Yet another point I want to make is about computational complexity of phonology, because I think that's a point where we clearly have restrictions. I basically pointed that out already. I pointed out that we know that phonological computations are very simple. I think that many people who studied computational phonology agree on that. So they fall at most in the class of regular languages, which is the bottom of the Chomsky hierarchy. So the simplest kind of formal language systems which Chomsky pointed out. Now after that, people have refined the hierarchy and pointed out there can be within the set of regular languages there can be even simpler systems. And phonology might be one of those, especially if we allow ourselves not ourselves, but the computation not to be about segments, but about autosegmental objects. Because then we can say phonological computations are always only about adjacent things, right? So you only look at things which are adjacent. But they're adjacent not necessarily at the level of the segments, but they're adjacent at the level of the autosegmental tiers. So, and then so if we allow this little refinement in the representation, which many phonologists would be willing to do, then we can have very, very simple phonological computations. There's no clear reason why that would be the case immediately, right? So there's no logical reason, that's the word I was looking for, why that would be the case immediately. You could have more complex phonologies, right? You can easily in your mind, you can easily make up more complex phonological systems where you have real long distance kinds of effects, right? So the first consonant always affects the last consonant of the word, or something like that. They always have to be the same, no matter what, in every possible dimension, or just in one dimension, whatever, right? So that it's easy to figure that out, but it doesn't exist. Phonologies of human languages are too simple for that. So what does that mean? Where does that come from, right? Where do these restrictions come from? There are restrictions on representations we've seen. There's restrictions on computation we have seen. Where do they come from? can we say, well, they're not innate because these systems can learn them? Well, these systems can learn basically anything. I did also experiments where I try to teach uh, ChatGPT, again in this case, simple artificial languages. Like in artificial language experiments we do nowadays with human speakers. Now, this is a very strange kind of artificial language. I was teaching it here because it has some kind of, so there's some kind of place effect, but the place effect is all over the place. So if a word ends, if a stem ends, and nominative ends in a labial sound, you get a velar ka suffix, accusative suffix. If the nominative ends in a coronal sound, you get the labial pa suffix. If the nominative ends in a velar sound, you get the coronal ta suffix. There's one example of a vowel, blow. If it ends in a vowel, you get bloa. And then I give it a number of nominative forms and ask it to give the accusative, right? So can it get the pattern? Now, this is an unnatural pattern. I have to say this experiment is too small just for the purposes of presenting it here on one slide. So it should be a bit bigger. You should have more data and stuff. But the question is, can it now do that task? Humans would find this task more difficult than a task which is more natural, right? So it's an unnatural task. ChatGPT can do it, although in a strange way. Again, it insists on first giving an analysis. That analysis is crazy. So, and actually the real answers, which it gives later, are basically correct. Not all of them, but in many cases it is correct. Um, but the analysis is crazy and it doesn't recognize anything like features or stuff, right? So it puts M, R, P, and F together, whereas the R really doesn't belong there. It's not a label sound. No, in none of the examples is an R followed by K, etc. And then L is put separately as well. Whereas it also, according to the system, needs to have K, and then it doesn't generalize over to vowels when it sees all. So it doesn't have this kind of capacity. It doesn't have that kind of capacity for generalizing over vowels when it has to make some kind of theory, which I didn't ask it to do, but it does it without asking. But it also doesn't do it when it does try to do what I ask it to do, namely to just give the accusatives. So when I give bose, it says not bose a, but for some reason, nobody knows what reason, bose pas. Yeah, so it makes, on the one hand, it does it suspiciously well because it learns some kind of a natural pattern. At the same time, it doesn't generalize at all. And again, this is a toy example just for presentation, but also in longer examples, it doesn't seem to do it well. Yet another point is this one, right? Or maybe it's connected, right? So the point is this: it seems to be able to learn all kinds of patterns, right? It just doesn't generalize when it doesn't have data. So when it doesn't have other vowels, it doesn't generalize to other vowels. So it's very strict, but it learns patterns and it's extremely strong, and it learns crazy patterns just as well as non-crazy patterns. So it's not bothered by these restrictions. So it means this is a computer which has enormous power and has enormous data and can learn language. Is that surprising? Should that be surprising? Maybe not. Maybe not. But does that tell us anything about the necessity of innate knowledge for humans? Well, why? Because we don't have this enormous computational capacity. Maybe our computational capacity, it has surpassed our computational capacity. It definitely has surpassed our input. So that's what some people have pointed out, right? So it has learned has been trained on billions of words, hundreds of billions of words, maybe even more. This is just GPT-3. We're now at GPT-4. Uh, so that means, this calculation says, well, it means that it would require a human being to read non-stop for like 1,000 years to get at that level. So we're more efficient learners than them. Now people work on this, say, yeah, but that's true, but we have the advantage that we don't just learn on the basis of just text, right? So we also get input from our parents. We can see the world while it is being described in language, etc. So we have, maybe our input is actually richer. That's an open point. Still, the computation. So these machines, because they seem to be able to get just any kind of pattern. If there is a pattern, they get a pattern. That's not what human beings are, right? So we have some kind of bias. So maybe that's still not really an argument against us knowing these structures. And otherwise, we have to wonder, where do these constraints we observe come from? Why is phonology so simple? If systems can also learn complex systems, why are phonological objects relatively simple? Why is whatever your theory of syllable structure is, that's never very complex, right? So why is that? It's easy to imagine much more complex kinds of constraints on what is a possible syllable than human languages attest. Why don't we find that? So these systems can learn natural language effortlessly. It's true. But then the question is, so that you can say that's not an argument for innateness anymore. But now the question becomes, where do these constraints come from? So maybe they do come from humans, right? They're there because humans are there. And machines with this small power which humans have still couldn't learn, even if we would be, if you give an, I don't know, if you give us simple humans nothing to guide us, and only statistics and 911 years of reading, we still don't get anywhere, right? With our simple brains. Maybe that's the case. I don't know, but maybe that's the case. So it's also not a wonder then. So it's not a wonder that these systems, which seem to be more powerful, maybe than us, so they're more powerful than phonology, right? So their power is more powerful than the kind of sub-regular languages we need for phonology. So it's no wonder that we can learn them. But why is it? There can be other explanations too, right? As I say here. So there can be explanations from evolution, from evolutionary phonology, that some people would prefer that. They would say, well, in the transmission from one generation to the other, it's a natural thing for systems to become simpler, right? So maybe that's what's going on. It's just, or in the communication, systems tend to become simpler. But then I need to point out that the term learning for these, or even training for these large language models, is of course a metaphor, right? They're learning. Yeah, what does it mean? It's not. It's by definition not exactly the same as what we are doing. It's definitely, you can compare it to learning, and learning is not a bad metaphor, but there are other metaphors as well. We know that in the biological world, evolution has many properties in common with learning, but then at the species level rather than at an individual level. So I refer here to the work of Daniel Dennett. So a species evolves into another species because of adaptation, right? So adaptation is a good example. So it adapts. So we get a new species which is more adapted to the circumstances. That is like learning, right? So it has the circumstances where the species didn't really fit the circumstances very well. Then it died out. Now there is a new species which is adapted. That is like learning, right? It's just learning. It's not like any individual is learning. Okay, let's now do this or this. It's a species which is changing so that it now fits better. And there is no reason to not call what's happening without these large language models evolution rather than learning. It's just that's another metaphor you could use. And in linguistics, we have two different kinds of evolution, one of which is also a metaphor. So there is biological evolution uh, potentially, which would explain certain kinds of innate properties of the human mind if you believe that those exist, right? So, and that can also be mimicked by these systems, right? So, and then there's cultural evolution. So there is the kind of evolutionary phonology evolution, which could explain how natural languages uh, evolve over time by some kind of mechanism, which is then metaphorically also similar to biological evolution. Like many languages have this mama property, that mama or something like that refers to parent, at least a parent. Well, okay, there's maybe some kind of cultural reason for that, right? So, as we know from Jacobson, so that languages tend to easily move in the direction of having that. Cultural evolution can also be mimicked by these machines, and that can also be a metaphor of what they do. So it's already difficult to distinguish sometimes between biological evolution and cultural evolution when we study language, simply because we don't really know what the history really was like and how old certain properties are and stuff. But for machines, it's even more difficult. So it's to say, well, the machine has learned language. ChatGPT or GPT has learned language is one way of saying it, and then you can say, well, so it learned language and it started as a blank slate. But you can also say, well, it started as a blank slate and then it developed, it evolved into a system, which is the system which we have now. So it is very well possible, at least in principle, that these machines have at some point do have also segmental representations somehow internally. We discover that because they have discovered that that's the easiest way to deal with human language. But then that can be seen as some kind of, at least in my view, a computational evolution rather than computational learning. And then, as an aside, these machines themselves, uh, these machines themselves also evolve. Right? They also become more and more. They become better and better. That's what I should say. So GPT-3 and GPT-4 have been mentioned several times in this talk. Now, I use GPT-4, which is the latest version, and then OpenAI, the company which makes it, tells me every once in a while. Let's say today, I think I'm working on version September 25. I don't know what it means, but that version changes every once in a while. And I assume that is because this version is supposed to be better than the previous version. And I have to say that sometimes shows as well, right? So they become better in certain tasks. It couldn't, a few months ago, it couldn't do rhyme in Dutch. Now it can. So somehow it has evolved to do that, or it has learned to do that. The last property I want to talk about is modularity, um, which is another thing which is challenged at first blush by these large language models because they're extremely unmodular. So we linguists tend to think it's very important to distinguish syntax from phonology, at least, and maybe within phonology, I don't know, subsegmental phonology from suprasegmental phonology and stuff. Um, these models, they are completely monolithic, right? They're just doing statistics and they don't care about what. Uh, Now that again is a description of the initial state and not of the final state of these machines. So we don't really know whether they can do their tasks because we cannot look inside, right? That's a big problem of these models. We cannot really look inside, so we don't know whether they don't actually somehow distinguish between the syntactic structure of a sentence and the phonological structure. Although, yeah, as we said, prosodic structure is probably lacking because it doesn't have spoken words. But in any case, but also it is something which is so, to the extent that this is not the case, it has been demonstrated already that this is potentially one of the problems of these models, that they are not sufficiently modular. This has been demonstrated, I have to say, at higher levels, namely that very likely, at least I find the arguments convincing, very likely we need to distinguish more between linguistic knowledge and knowledge of the world, or knowledge of truth, interest in truth, and things like that, interest in my partner. These models, they only learn text, and they only learn what is the most plausible next word, next letter in a text, and therefore, what they know about the world is basically also what I know about a cat is what's the most likely word to say after cat, right? But that's basically what I know about cats. That means people have pointed out that some of the problems which we know exist with these chatbots are probably related to that. So the fact that they make things up all the time, right? So they hallucinate. They don't care about facts. Even if you tell them to look up whatever they want to say first at Wikipedia, they still very often give you nonsense rather than what they have read on Wikipedia. Why? Because they don't care about the truth. They care about saying the thing which is most likely, combined with saying what you are most likely willing to hear according to them. It also means you cannot really it's very difficult to update their knowledge. It's very difficult to tell them now, this person is dead, right? So I don't know, the Queen of England is dead. That will probably take some time for that to get into the system's heads, because you would have to tell them separately. Otherwise, there's so much data that the Queen is not dead. So much data that the Queen is not dead that it will be difficult for them to learn that the Queen is dead. So you would need to separate this so that they have some kind of fact-based somehow, I don't know, and that the language models only care about saying it correctly, whatever they want to say, and that's modularity, right? So modularity might be lacking, and that might be true also for some of the problems in syntax or in phonology, that they're not sufficiently modular. And that's very exciting and interesting to try to find that out, right? To try find out, could the linguistic input, output, their reading, their writing, could it improve their speaking? Could it improve by adding certain kinds of ideas of modularity? So this is where real technology could maybe inform us about what's the reason, again, that language seems to behave in a modular sense, right? So it seems to be the case that in human so syntax and phonology are different in what kind of objects they talk about, how they do their computations, etc. They seem to be almost completely invisible to each other, because syntax doesn't see any phonology. We know that phonology sees some parts of syntax, namely syntactic structure, but not labels, or at least not most labels. It doesn't really seem to see semantics, etc. So why is all of that? If our brains are so monolithic as well, why would all of that be? So we just can ask our questions, but we can ask them in a new way, informed by these models. And that's why I think that these models are a good thing. There's reasons, completely independent of this, there's reasons to think, to be worried about them, right? There's reason they cost lots of energy, for instance. That's a big problem. There's all kinds of societal reasons to worry about them. The people who trained them were very often underpaid workers. They are one of the biggest problems too. They are the property of companies, commercial companies, and it's a long time probably since some very important, powerful new tool was in the hand only of companies and not at universities, right? So academics, also our colleagues, computer scientists, computational linguists, they have less access to these systems because they are owned by these companies. So, but I think that mostly is an argument for trying to work on those things and trying to make sure they're extremely expensive. So an individual university cannot pay for them. But to try to make sure that we, I don't know, open source people, universities working together around the world, try to build something and make it efficient and make it fair and not use low paid workers from the global south, etc. Right? So that there are definite problems and they might block you, and maybe rightfully so, from using these systems now, but they're not inherent to this invention of these large language models. And even as thought experiments, they are important. Right? So it's important that they are there and that they can do certain things. And I'm actually convinced that we need to study them. We, formal linguists, formal phonologists, we need to study them. We need to find proper experimental methods to explore their linguistic capacities. I've been showing that it's not just that they do things wrong, but they answer them in such a way that, you wouldn't like that with informants. At least I wouldn't like that if they would always immediately start give you an analysis of what they think is going on. Oh, this is vowel harmony, right? That's not what you want. You want to have their intuitions. And I have found, maybe it has no intuitions, or maybe I have found no way to access their intuitions. And that's something I think we need to find out. And then, because that opens a way to explore these constraints we have already found, and maybe find more of them on what natural language is, and to try to understand, where do they come from? Is it necessary to first evolve as a computer, as a human being, or as a biological being into something like human mind before you can use it, and have these systems secretly very quickly evolved into these kinds of human minds? Is it something you can learn and you don't need? Do these systems really do it without any of this? And then, could much simpler models also do that? I think so. My message is, it's really too important to not study these things. I think we should.